Welcome to the course of Introduction to Data Science. In this week, we will cover chapter number 2 of our textbook, which is about data. So data definitely in data science, or you can say data science is a data-driven approach. All the actions, all the algorithms, all the models are primarily based on data. So definitely data is the most important thing when you are doing data science. So let's start with 2.1 unit, or the first unit of this lecture. Okay, so in first unit, which is actually about data types. So we can explain data types in many aspects. If you are from programming background, then you might know about it that in programming we call it integer, float, string, maybe decimal, maybe boolean, maybe other types. So these types actually represent that which type of data the variable can contain or can store. So if you talk about integer, then of course only store number without decimal. And if you are talking about float, then it can store numeric values with decimal. And if you talk about double data type, then basically it contains again numeric values along with the decimal, but the precision is comparatively larger than the float type. Or maybe you can say if we just approximated that the double type contain basically almost the data which is double in size in comparison with float type. Okay, generally it's again depending on the programming language. If float type is of 2 bytes, then double is of 4 bytes, or if float type is of 4 bytes, then double is of 8 bytes. So it's actually depend on basically which programming. In modern programming languages, generally float is of 4 bytes and double is of 8 bytes. So this is basically generally whenever as a computer scientist or a programmer, whenever someone tell you about data types, then the concept usually arrive in your mind is about these types, like what we have, what I have already explained, that integer, double, float, or boolean, or something else, right? But here in the context of our data science, we are categorizing, we are actually defining data types as structured data and unstructured data. So rather than basically going to whether it's floating type or a double type or something like that, we are just emphasizing or focusing on the concept which is basically, which actually distinguishes data into two categories or two types. One of them is actually the structured data and the other one is actually unstructured data. So if you can see here under the data types, we have structured data, and you are very well aware that for example, if we take example of relational databases, so in the relational databases you may have multiple databases. Again, if you are using any type of a relational database management system, you may have basically multiple databases, and in each database you may have one or more tables. Okay, so in basically we may have basically one or more tables. So you know it very well that in relational database tables, the data is very well structured. Okay, very well structured means that each table has basically associated number of columns. Each column have basically specific types and some other constraints associated with each of these columns. Like for example, if you just talk about for example primary key, then primary key is maybe have any integer, or you can say numeric, or maybe a string as well, data type, and along with that there is a constraint which actually primary key actually ensure that the value contained in the primary key column must be unique. No matter how many tuples you have in a table, maybe 100 or 1000 or millions or billions, but all tuple have basically unique value in primary key column. Okay, so this is basically just an example of a structured data. And tables in relational database is one of the best example of structured data, and you know it very well. And if you can further define that in table there is an associated schema, so what we are actually talking about, that it contains number of columns, each column has basically their associated types, may have basically some constraints, like unique constraint, like basically, you know, again the primary key, like actually foreign key, like maybe not null or null or something like that. So it is a very well defined structure imposed using metadata or the schema associated with the table, and it is the responsibility of the database to ensure the schema whenever someone is actually adding, removing or editing a tuple. Means if you have basically defined a column as numeric, then it will not allow you to insert anything non-numeric. Okay, if you have defined a column as nullable, then you can insert empty or null, actually it's better to call it null, no values. Or if you have defined not null constraint, this means you cannot able to insert null value in that particular column. And similarly for the primary key, that it should ensure that no two tuple have same values in primary key column. So this is structure. So it's very easy to work with the structured data because everything is actually fixed, well defined, well maintained, and all the constraints are automatically imposed by the database management system. Definitely you have to define, but it is the responsibility of the database management system to ensure everything which is defined by you. So in modern world, you know it very well, all the old DB systems or online transaction processing systems are primarily based on relational databases, and in relational databases, you know, you have tables. So it is very easy to work with structured data. You can perform all the possible analysis to get some insight about the data, to compute something, to aggregate, or anything you want to plot. Like you might need to create an MIS report to better understand about the transactional details stored in your basic database about maybe your product selling or something else. Okay, so working with the structured data is, you know, it's quite easy, quite flexible, and in most of the cases, specifically in transactional system, we primarily use structured data. But there's another type of data which is actually unstructured data. Unlike structured data, for like tables which we have talked about, unstructured data is in free form. Okay, and that is why it actually imposes a big challenge. This is not easy to deal with unstructured data. It is not easy to get an insight from an unstructured data. Okay, so but remember, in comparison with the structured data, unstructured data is comparatively much large in size. But most of the organization and for most of the analysis we ignore it, and that is why we are losing opportunity which we can get. If we can incorporate, if we can use unstructured data, then we can take a strong benefit, or maybe we can take edge from other organization or maybe from your competitors. But we are actually losing this edge. We are not utilizing it. We are ignoring it. The reason is basically because of the complexity associated with the unstructured data. And that is why the lack of structure makes compilation and organizing unstructured data a time and energy consuming task. it's lots of effort is required, and that is why I already explained that people usually ignore it. Okay. Of course, the problem that unstructured data present is one of volume. I told you that the volume of unstructured data is generally much larger than structured data in an organization or at the global level. Okay. Most business interactions are of this kind, requiring a huge investment of resources to sift through and extract the necessary element, as in a web-based search engine. You know it very well. Again, websites are actually having unstructured data, so it is very difficult to get data out of millions of websites. But thanks to the technology, or thanks to the platform provided by the search engine, or the interface, or the easy interface provided by the search engine, through which you can easily able to find meaningful data or the desired data out of million and billion of websites. Okay, let's take an example of maybe Google. You know it very well. We all use Google or some other search engine to find out to search some relevant website from the internet, which if we want to do it manually or some other technique or some other way, it will be very difficult. But because of this very powerful web search engine having very complex algorithm associated with them, and highly scalable architectures associated with these search engine, you are able to search your desired information from huge web sites. Okay, so anyhow, and because this pool of information is so large, current data mining techniques often miss a substantial amount of available content, and definitely much of which could be game changing if efficiently analyzed. So again, I'm already explained that if you can incorporate unstructured data in your analysis, in your in your process to have an insight from the data, maybe to use for your strategic decision making. But if you are skipping this, then you are losing opportunity. And if somehow if you can incorporate this unstructured data within your analysis, okay, then it might be game changing. You might take much better decision. You might make it might help you in taking powerful strategic decision making. And that is why most of the organizations are now moving towards unstructured data within your analysis, within their data analysis strategy, within their data science strategy. So previously, most of the organizations just relying on the structured data to get an insight, but now all organizations are basically realize that unstructured data is very meaningful, and that is why we need to use unstructured data within our overall analysis or data science process. Okay, and you know it very well. There are basically techniques like information retrieval techniques or text binding techniques, which actually in the last maybe over a decade basically proved themselves that they are actually able to perform very powerful analysis on these unstructured data. Like for example, let's take an example of text summarization, topic modeling, or sentiment analysis. Okay, so these are few of the techniques or approaches or algorithm which very frequently used by many organizations to understand the behavior of their customer, to understand the behavior of their employee, to understand the sentiment of basically the people or the customer or any other user. That is why now we can say that organizations realizes that along with structured data, unstructured data are also very important, and with the help of the modern techniques like text mining or information retrieval techniques, they are able to get a better insight of the from their overall data, which actually comprises of structured and unstructured data. So with this, I want to conclude our unit number 2.1, which is about data types. So in the next unit, we will further talk about some more concepts relevant to data and its importance. Thank you very much.